Welcome back. In the last video, we showed how the actuator could work with databases to build complex applications. The actuator dynamically built special inverts that communicated with stored procedures in the database. No logic was needed, nor any specialized database knowledge. In this short video supplement, we will show you some more advanced database inverts. You will see database inverts whose in and out parameters are not singletons but sets. These correspond to multiple calls to the same stored procedure. You will also see how these inverts can interact with each other to specify software of enormous complexity. Let's take a look. So here we are back at the phpMyAdmin tool, looking at the classic models database that we saw in the previous video. We're interested in a couple of tables as well as some stored procedures. This first table is the employees table, and the fields that we're interested in are the employee number, last name, first name, and then the employee number of the person they report to. We'll also look at the product lines table, and there are 7 rows in this table. We'll also look at some stored procedures that we've set up against this database. And again, we showed you these in the previous video, but in particular this time around we're going to be looking at tab employees. The tab employees basically summarizes for you the list of the employees that report to a particular boss. So 1102 here, if we run that, it brings back these 6 people here. If we run it again and we type in the number 1056, this is a different boss, and this boss has 4 people reporting to them. Just go back to these subroutines again. We'll also be looking at several of these that perform actions against the database, for example, inserting, updating, and deleting. So let's go back to the actuator, and what we'll be focusing on this time around are the ++ versions of these inverts. Every one of these pretty much has a 1 or a ++ version. The 1 version uses singleton input parameters. The ++ uses collections or sets of parameters. And so basically, if it's a ++, that means it's going to run it multiple times. To save time, I've set up some of these programs here just to illustrate this feature. Here you can see the DB table ++. It pulls in employee number, last name, first name, and who they report to. But the boss here you see is a set given by the double lines. I've actually set this up ahead of time over here. This is a link to a set of 2 numbers, 1056 and 1102 that we just saw. And then once we run this, it's going to run it twice basically, and then it's going to collect everything into a single output set of data fields. And we're just going to look at the first name here. You can see this reference from here to here. We run it, click OK, and there are the 10 people. Let's also look now at some inverts that perform actions on a database as opposed to just reading it. So we'll pull this out of the way. I've set this one up also ahead of time. In this case, we're looking at a DB table 1, but it's only looking at a single boss here, number 1056. You'll recall that there were 4 employees reporting to that boss. So this is going to run and bring back 4 sets of these data fields. And what we're going to do is we're going to perform an insert against 1 or more database tables. In this particular case, the insert that we have here, insert product line, inserts a row into that product line table. Now, because it's a ++, that means that all the parameters here are going to be sets given by these double lines. And if you can just ignore the fact that we're mixing and matching different types of data here, the main point here is that these are text fields. So we're going to take the first name and the last name, and those are going to be inserted into the product lines database here as the product name and the product description. So basically, we're going to run this thing once, and it's going to spit out 4 sets of records, and each one of those is going to drive multiple inserts against that product lines database. And if we run it quickly, first let's look at the database. Let's look at the product lines database. We'll give it a quick refresh just in case. It's got 7 rows. Now we'll come back here. If we run this, we're going to insert hopefully 4 rows into that database table. We'll refresh it now. And there you can see 1, 2, 3, and then 4. As I said, these are meaningless text fields, but they illustrate the functionality here. Let's see if we can update that data now. So I'll pull this out of the way. And again, I've set this one up ahead of time. Same thing, we've got a table 1 reading in a tab of employees, all reporting to boss 1056. There's going to be 4 of these people. And what we'll do this time is we'll use the first name again as the key, it's the first element of that table. And what we'll do is we'll update it so that instead of the description pointing to the last name, it's going to point to the first name. If we just quickly run this. So it's built it and run it already. Let's refresh over here. Hopefully, there you go. You can see the text description now matches the product line. And then the third or the fourth example I've set up is an example which, again, we're going to read in all the employees reporting to boss 1056. There's 4 sets of these fields. And for each one of these are sets, it's going to drive this db delete ++. And what it's going to do is for each first name, it's going to delete that record. Run it once, click on that. It's already built it, it's already run it. Let's refresh this. And now you can see we're back to the original 7 records. As I've mentioned previously, these stored procedures are not limited to a single table. When we delete something, we're not deleting necessarily just a single row. These could be deletes against multiple rows, perhaps across multiple tables. It all comes down to the design of the database and how you set up your stored procedures. But hopefully we've shown here that there's a rich variety of operations that you can perform here with the actuator against databases. And just to reiterate what I've said before, there's no logical instructions required anywhere. So to summarize, you saw database inverts with sets of parameters corresponding to repeated calls to stored procedures. You saw some complex interactions between these database actions. We showed you 4 simple programs in their entirety, and they could each be specified in less than a minute. Thank you for watching, and we'll see you next time.